the science behind everyday illusions that trick your brain, how your mind deceives you every single day, without even realizing it. Your brain plays tricks on you. From optical illusions to cognitive biases, your mind is constantly filling in gaps, making assumptions, and interpreting reality in ways that don't always match the facts. It's not a flaw, it's how evolution shaped your brain to survive in a world full of incomplete and complex information. The fascinating part is that many of these illusions are so seamless, so automatic, that you don't even question them. You trust your senses and your instincts, even when they're wrong. This is not just about magic tricks or optical puzzles, it's about how you perceive color, motion, space, and even time in everyday life. Understanding how and why your brain falls for these illusions can change the way you see the world, and yourself. It can also make you a sharper thinker, more aware of your own mental shortcuts and errors. After all, to outsmart your brain, you first have to know how it works. Today, we're diving into the science behind everyday illusions that trick your brain. From impossible shapes to false memories, get ready to question your reality, because nothing is quite as it seems. The Müller-Lyer illusion, when lines lie to you. One of the most famous optical illusions is the Müller-Lyer illusion, where two lines of identical length appear to be different because of the arrows at their ends. One line has arrows pointing inward, and the other has arrows pointing outward, making one seem longer than the other. Your brain is trying to interpret these lines in three-dimensional space, based on everyday experiences with perspective. Arrows pointing inward suggest depth, like the corner of a room, while outward arrows suggest an exterior corner. Your brain unconsciously adjusts for this depth cue, stretching or shrinking the line accordingly. Even when you know the trick, the illusion still works. This shows how hardwired these processing shortcuts are. They're not based on conscious thought but on deeply ingrained visual habits. Your brain isn't trying to deceive you, it's trying to help you make quick sense of the world. The Müller-Lyer illusion highlights an important truth: perception is not reality. It's an interpretation, and sometimes, that interpretation is wrong. The color constancy illusion, why that dress broke the internet. Remember the viral debate over whether a dress was blue and black or white and gold. That phenomenon is a classic example of color constancy, your brain's effort to keep the colors of objects consistent under different lighting conditions. When light hits an object, what you actually see depends not just on the object's surface but also on the color of the light source. Your brain automatically compensates for this, adjusting colors based on the surrounding context and ambient light. Sometimes, different brains make different assumptions, leading to wildly different perceptions. In the case of the dress, some people's brains interpreted the lighting as shadowed, making the dress blue and black, while others assumed it was brightly lit, seeing it as white and gold. There was no right or wrong answer, only different assumptions. This phenomenon reveals just how subjective and variable human perception can be. Reality isn't just what's out there, it's what your brain decides you're seeing. Motion after effects, why waterfalls move after you look away. If you've ever stared at a waterfall and then looked at the rocks beside it, you might have noticed the rock seemed to move upward. This is called a motion after effect, and it happens because of the way your brain processes motion. Neurons in your visual system are specialized to detect movement in different directions. When you stare at continuous motion in one direction, those neurons become fatigued. When you look away, the less fatigued neurons for the opposite direction briefly dominate, creating the illusion of motion where there is none. This isn't just a visual curiosity, it shows how your brain balances incoming information by constantly comparing competing signals. Motion perception is a relative process, not an absolute one. The waterfall illusion reminds us that our senses don't just passively receive the world, they actively interpret and, sometimes, invent experiences based on internal processing. The hollow face illusion, when concave becomes convex. The hollow face illusion is a powerful demonstration of your brain's preference for familiar interpretations over logical ones. If you look at the inside of a mask, a concave, inward, surface, you will likely perceive it as a normal convex, outward, face. Your brain is so accustomed to seeing faces that it automatically flips the concave image into a regular face. It overrides sensory information because assuming faces are convex has been more useful for survival, helping to quickly identify people from a distance. Even when you approach the mask and your rational mind knows it's hollow, the illusion persists. It's a powerful example of top-down processing, where what you expect to see shapes what you actually perceive. The hollow face illusion shows that your brain isn't just a passive recorder of reality, it's an active constructor, constantly filling in blanks based on assumptions and past experiences. Change blindness, how you miss obvious differences. Imagine watching a movie where, between two cuts, a character's shirt changes color, and you don't even notice. That's called change blindness, and it's surprisingly common. Your brain prioritizes continuity and the big picture, often missing significant changes in your environment. Attention is a limited resource. Instead of analyzing every detail, your brain uses shortcuts to focus on what it thinks is important. When a change occurs during a visual disruption, like a flicker, a pan, or a blink, you're less likely to detect it. This phenomenon reveals how perception isn't a perfect snapshot of reality. It's more like a rough sketch, filled in by memory and expectation. You assume that most of the world remains stable because, most of the time, it does. Change blindness highlights how our brains sacrifice detail for efficiency. We live not with a complete view of the world, but with an impressionistic one, just detailed enough to get by. The Ebbinghaus illusion. When size is all about context, the Ebbinghaus illusion shows two circles of identical size placed near other circles, one surrounded by larger circles and the other by smaller ones. Strangely, the central circle surrounded by larger ones appears smaller, even though both are the same size. Your brain interprets the size of objects relative to the things around them. This illusion taps into a critical survival instinct, judging size and distance quickly. In nature, knowing if something is bigger or smaller than expected could mean the difference between food and predator. Context heavily influences our perception, often more than the raw sensory data. Even when you are aware of the Ebbinghaus illusion, the brain struggles to correct itself. That's because the visual system evolved to prioritize relational information over absolute measurements. It's quicker and usually good enough for survival. The Ebbinghaus illusion proves that context isn't just helpful, it actually shapes the way we perceive basic attributes like size, fundamentally altering our view of the world around us. The McGurk effect. When sight changes sound, imagine hearing ba but seeing someone's lips form fa, and suddenly, you perceive fa instead of ba. That's the McGurk effect, an amazing example of how your brain integrates information from different senses to create a unified experience. The McGurk effect demonstrates that what you see can dramatically alter what you hear. Your brain combines auditory and visual cues to produce a final perception, and when they conflict, vision often wins. This multisensory integration usually works to your advantage, helping you better understand speech in noisy environments. However, it also means that your perception is vulnerable to manipulation. In situations where visual and auditory inputs don't match, your brain doesn't notice the discrepancy, it simply blends them into a new, third experience that feels totally real. This effect highlights how the brain's goal isn't to record reality perfectly, but to create the most useful and coherent interpretation possible, even if that means fabricating part of the experience. The Ames room. When perspective breaks your brain, the Ames room is a specially designed space that looks like a normal rectangular room when viewed from a specific angle, but it's actually a distorted trapezoid. In the Ames room, one person standing in a corner appears gigantic, while another appears tiny, even though both are normal-sized. Your brain assumes that rooms are rectangular because that's what you encounter every day. It automatically corrects the angles and scales based on this assumption, creating a powerful and convincing illusion of size difference. What's fascinating is how quickly and completely your brain buys into the deception. Even when you know how the trick works, the illusion remains stubbornly convincing. The architecture of the room exploits your brain's basic rules for interpreting three-dimensional space. The Ames room is a vivid demonstration of how easily our deeply ingrained assumptions about perspective and geometry can be manipulated, and how little conscious control we have over our immediate perceptions. The Stroop effect: when words interfere with colors, try reading the word blue written in red ink and saying the color, not the word. It's surprisingly hard. This is the Stroop effect, where the automatic process of reading a word interferes with the task of naming the color of the ink. The Stroop effect reveals how automatic certain cognitive processes are. Reading is so deeply ingrained that it becomes nearly impossible to suppress, even when it's counterproductive. Your brain has to fight its own habits to complete the task correctly. This struggle illustrates the concept of cognitive interference, when different pieces of information processed simultaneously compete for your attention and response. It shows that your brain prioritizes speed and efficiency over strict accuracy when juggling multiple tasks. The Stroop effect teaches an important lesson about attention, habit, and conflict in the brain. It's a powerful reminder that what you intend to do and what your brain reflexively does are often two very different things. Phantom vibration syndrome: when your brain invents reality. Have you ever felt your phone vibrate in your pocket, only to check and find that nothing happened? That strange sensation is called phantom vibration syndrome, and it's a modern example of how your brain sometimes invents sensations based on expectation. Your brain is constantly predicting what should happen based on your experiences and habits. When you frequently receive notifications, your mind becomes so attuned to those signals that it sometimes fabricates them, a false positive designed to be cautious rather than miss something important. This phenomenon shows how expectation can literally create sensory experiences. It's not that you imagined it in a playful sense. For a moment, your brain genuinely produced the sensation of vibration. Phantom vibration syndrome is a vivid example of how the brain's need for efficiency and prediction can blur the line between real and imagined, a reminder that reality is not just experienced but also actively constructed inside your mind. Throughout this journey, we've seen just how easily and how often our brains deceive us. From colors that shift based on lighting, to sounds that change when paired with mismatched visuals, to sensations that exist purely because we expect them, the mind is a master illusionist. What you experience every day is not a direct reflection of reality, but a carefully constructed version shaped by millions of years of evolution and adaptation. These everyday illusions aren't signs of a flawed mind, they are proof of an incredibly efficient system designed to make quick, often life-saving decisions with incomplete information. Your brain fills in gaps, smooths over inconsistencies, and creates a seamless version of the world so you can navigate it swiftly and safely. In most cases, these shortcuts work beautifully, but sometimes, they reveal just how fragile and flexible perception really is. Understanding these tricks gives us a deeper appreciation of how complex our brains truly are. It teaches us to be more humble about our senses, more skeptical about our first impressions, and more curious about the hidden workings behind every experience we take for granted. Reality, it turns out, isn't just out there, it's crafted inside your head, moment by moment. If you enjoyed learning about the amazing science behind everyday illusions, don't forget to like the video, subscribe to the channel, and comment below which illusion surprised you the most. Stay curious, stay questioning, because in the world of the mind, things are never exactly what they seem.